Okay, I want to do a video about climate change. Climate change is a phenomenon that was misrepresented in the beginning. After that, it was ridiculized, and now we actually having difficulty to understand the severity of climate change, because we tend to procrastinate and send everything further to say it's okay now, and tomorrow we do it, everything, we will diminish the carbon print, and we will diminish CO2 emissions, and we will dedicate ourselves to finding the right technology to absorb all the CO2 from the atmosphere and to mitigate. It's a nice word, mitigate, but what is the meaning really? What is mitigate? CO2 presence in the atmosphere. We are putting CO2 in the atmosphere from the 80s, so we already have a lot of CO2 there. We have 1 degree of centigrade temperature increase that's causing the glaciers to melt, and much more phenomena of the desertification and inundations and so forth. And we tend to think that climate change is something that is linear. It has a linear way. It's gradually going from 0 change to 1 degree change, and maybe in 40 years we will have another 1 degree change, and who knows, maybe in 100 and 200 years, if we do nothing, then it will get to 3 centigrade change. But the thing is not like this. Now we begin to understand that actually climate change is something that is accelerating all the time. It's a phenomenon that is more similar to an exponential curve than to a linear curve. It's maybe some people will tell it openly, maybe other people will tell it in a little whispering, because they don't want to seem silly or something. But actually, we beginning to see that the process of the melting of the icebergs and the North Pole, maybe in the South Pole also, I don't know, is actually melting in an increasing rate. And we see that now it's 6 times faster than before. So these icebergs, the glaciers are melting 6 times faster than they did before. And this phenomenon is due to auto-feedback loops that are all over the place. All the climate change phenomenon is infiltrated with these feedback loops. For example, when the forest is burning, not only we lose the capacity of the trees to absorb the CO2, we also have emission of the CO2 from the burning process. When the glaciers are melting, not only they are not deflecting the light of the sun, diminishing the entrance of the UV rays inside the atmosphere, they are also we are also seeing more rapid heating of the water, because due to the transition, the phase transition physical phenomenon. If you have ice inside the water, you will take much more time to heat the water when there is ice inside than if you have a mass of only water without ice. It will take not much longer, but sometimes a little longer if you have ice inside. When you melted all the ice inside the water, the process will go more rapidly. So this is another phenomenon that I will talk about this later. Now I will talk about the buffer titration of the oceans. But I begin to talk before about the processes of feedback loops inside the phenomenon of climate change. I begin to talk about the icebergs. I talk about the oceans. I talk about the methane. Methane is beginning. It's a new player. This player getting inside the game, like in a big way, maybe 5 months ago, half a year ago. It's something that wasn't present before. Maybe it wasn't present, but much a lower rate. So actually we are talking about acceleration of all the climate change, all the processes that are driving it. Methane have 400 more capacity to be a greenhouse gas, to entrap the heat, than CO2. Also, there is an increase in nitrous oxide, N2O. That is laughing gas. If somebody don't know, maybe the planet wants us to laugh at something before we cook ourselves with methane. It's a good joke, but it's not so nice to be cooked. Also, we have the oceans. When we are consuming the capacity of the ocean to absorb the CO2, the oceans really are this is also a feedback loop, because if we are unable to have this ocean that is functional, in some moment we're not able anymore to absorb heat and CO2, so we are passing to a situation where is more accelerated heat. But actually, we think we have the notion that we can go with this, increasing the temperature of Earth until something like 100 degrees or 150 or 200. In reality, the things are not like this. It's enough for the planet to get heat 3 or 4 grades centigrade to go into a cascade. We are talking about exponential phenomenon where we lose completely the control of weather. We are when the seas losing due to acidification and heating lose the plankton. They are unable to produce oxygen. We are going in asphyxiation and hypoxia, but and obviously humans and all animals that are oxygen breathers or animals, and also some kind of cells and plants in some situation in the night. The cells plants also consume oxygen. We will be left with atmosphere full of CO2, methane, nitrous gas, maybe other sulfuric components, sulfuric acids that are similar to the atmosphere of Earth before it reached the production of cyanobacteria. before it reached the production of plants, before it reached the production of mass production of plants on the ground and in the ocean. So really we are looking now in a retro evolution of Earth. We are sending Earth from a situation where it's going to a nice atmosphere with its oxygen, with its all nice animals, with like heaven, like paradise or situation where everything is abundant, food, water, everything is clean, everything is good. We are, with our own hands, we are shifting Earth far from this scenario to a precedent situation where the atmosphere of Earth is poor of oxygen or lacking of oxygen, and we have actually full of greenhouse gases inside. So this process of transition from oxygen, nitrogen-rich atmosphere to an atmosphere rich of volcanic, maybe prehistoric gases, this is a gradual, obviously, I'm not talking it can be tomorrow or after tomorrow, but we are sending with our own hands, we are moving the natural processes of the atmosphere and the symbiosis between the atmosphere and the ocean from a situation where we have a healthy atmosphere that making possible for the human civilization, and also obviously for the animal, because we cannot live without the animals, to thrive and to prosper. We're moving from this situation to a situation where we are talking about a planet that is not able to support life. Obviously, somebody will say it cannot happen tomorrow. I know it cannot happen tomorrow, but we are not rightly evaluating some kind of dynamics in the process of climate change. Because if we're talking about the oceans maybe can be considered as a weak base. A weak base that is because we need the plankton and all the little animals inside need their basic situation, basic environment to build their little carapaces, so they absorb CO2 and carbonate with calcium and build their little home for them. When this situation of the weak base of the ocean is being disturbed, they will no longer be able to sequester, to absorb the CO2. But for now, the situation is the ocean is more or less basic. It's a base. It's getting acidified by the absorption of CO2 in enormous quantities because he is not letting the atmosphere to be too full of CO2, because the Earth is don't want to get too much hot, so the ocean actually absorbs this temperature. And we are seeing here a simple idea, a simple concept in chemistry, where there is a titration of base with acid. So we are talking about that we are adding to the ocean, little by little we are adding to it CO2. The CO2 unites with other components that make the ocean acidic, and the ocean is able for now, let's say, to absorb all the CO2, but the CO2 is going and growing and growing and growing, and the ocean is going a process of acidification, because like I say, these little animals, that little plankton, the algae, and more plankton than others, mollusci and others, they take the CO2 in form of calcium, they make it deposit on the ground, they make this this carbon actually inert. If the carbon is free in the ocean, in the water, it can get out from the ocean. It's getting out in form of CO2, and then we lose. So what the ocean does, the ocean is taking the CO2, it making it to be a carbonate, and then it sediments on the bottom of the ocean, and it cannot harm us, at least for the time being. Okay, we're adding, let's say that we are keeping with the same management of the environment. We keep adding CO2 to the environment, and this CO2 going little by little, acidificating the ocean. So in some moment, we're thinking this process is linear. And actually, this process is not linear. This process is abrupt. This process is extreme. It's radical. There is no linearity in this kind. The pH is very in this curve. We see a big difference in pH. Okay, and don't pay attention to the pH, to the numbers, because we are beginning here at a low pH and we're getting to a higher pH, but I'm talking now about a situation where there is a high pH and we're getting to a low pH. So I'm just putting it for an example, for this delta, for this difference. And actually, when we add to the ocean so much CO2, we see acidification of the ocean. This change can be abrupt. We don't know when it will happen. It's an incognita, we don't know, but actually the mechanism, the dynamics of this process is very clear. The titration of a buffer is abrupt, is very radical. The ocean is getting very acidic in the end. Okay, so far from the acidification of the ocean and the consequences of procrastination in the politics of CO2, and letting it all take its course by invisible hand. Maybe yes, maybe no, we don't know. We just keep burning fuel, and what happened will happen, we don't know. In some moment, this situation will flip and we'll stay without ocean, without oxygen, and the consequence is clear: hypoxia and death. Okay, so another process that I want to talk about is the process of heat. The ocean also absorbs the heat, and actually the ocean now is hot. Then we need to ask ourselves why the ocean is in this situation practically and not different. Okay. Also, the ocean is a buffer that absorbs heat. In some situation, when the ocean is hot enough, it cannot already absorb so much heat. So we are talking about a situation where I don't know exactly if the heat absorbance of the ocean will be similar like to this curve, because this curve is an acid-base titration curve. I don't know if the heat absorbance of the ocean will be something similar. Maybe now he's not so hot. In some moment, we're beginning to add so much heat to the system. We see also, maybe, I'm not saying that it will be like this or no, but there is a possibility that the ocean system absorbing so much heat at some point will not be able to absorb the heat we are giving it by the climate change, the global warming process, and then we will be having another feedback loop deriving from the incapacity of the ocean to absorb the heat. And so, adding to all the other loops we talk about, we also have the heat loop, when the ocean is too hot, is not able to absorb more heat. Okay, so this is the phenomenon that I wanted to treat. It's similar to the titration, acid-base titration. Maybe it can light some kind of ideas in somebody's head. Maybe you will accept it, maybe not. This is my personal idea. This the way I see it personally. I'm not making nobody think like I do. It is what I think. Okay, I'm not getting network now. We will talk now about phase transition. The situation when we have ice in the water and we are trying to heat the water. And this is in the context of the glaciers. We should never reach a situation where we lose all the glaciers. People think that when we lose the glaciers, then we are into the blue ocean phenomenon or the dark ocean phenomenon or the blind ocean phenomenon or into the sweet ocean phenomenon. The losing of the glaciers is completely unacceptable because we are talking about a simple phenomenon in physics that is called phase transition. Phases, there is a solid phase, liquid phase, and gas phase. Passing from solid to liquid is melting. Passing from liquid to vapor, to gas, it's boiling, maybe, I don't know exactly now. And going directly from solid to gas, it's sublimation. But the idea is that if we have the system with water, now considering water, we have the ice inside the water and we're adding joules to the system, heat, energy to the system, we will get the temperature will get up much higher when we don't have ice. So our buffer, actually, if we want to call it like this, or our stop, we can stop the signal, we can slow the process. Our brakes is the ice. This is the reason why we shouldn't never lose the ice. This is somebody says that if we lose the ice, then nothing happens. This is not, it's not reflecting itself on the physical doctrine, because this is actually the situation. Okay, so in this here, we have the ice here in this place here. There is ice inside the water. This is the temperature. T temperature, and this is the temperature is almost constant in the beginning. We are giving heat to the system, and the temperature actually is more or less constant because there is ice. Here we have ice. Here all the ice is melted, so we have a abrupt change in temperature. The temperature, like you see, go from here to here in very short time. This is time. This is time. This is temperature. So as we're going to add the energy to the system, we have ice here. Here in this point, we already don't have ice. All the ice is melted here. So the transition between this point and this point, the temperature is going up because there is no ice. This is common physics. This is not something that I don't know what. Okay, so we never should lose the ice. The ice caps are being there for lots of let's say lots of functions, but the prevalent is to deflect the light from the outer space, from the sun. And the other function that I can recall right now is that they are cooling the ocean, the ice, not letting the ocean to get too much hot. So when we lose the ice, if we continue to give joules, we continue to do energy, heat to the system, the transition is very inclined, very rapid, very brusque, abrupt change in temperature, going from here to here in short period of time. Short period of time. So here, temperature, here, time, and our inclination here, tangents. Somebody want to talk about trigonometry? Tangent is much more abrupt than we have ice. When we have ice, there is constant, almost constant temperature. When we lose the ice, it's a game changer. Okay. Another thing, some people, some doctrines say that climate change is linear. Or maybe they don't say it in full view. Maybe they don't talk about it in like they don't want to be too much how do you say, they don't want too much to be politically incorrect. So they make you think this the climate change process of heating, of global warming, is a gradual, like very subtle and comfortable situation where little by little for thousands of years the earth is getting warmer, and maybe it's something natural, and we are going maybe it's artificial, maybe we're accelerating the transition of the nature. They say maybe, we don't know, maybe it's a natural phenomenon and we are only moving it, we are giving a push to it. Maybe we're a catalyst, maybe we doing not so much maybe it's hitting so little, only 1 grade centigrade. So they say it's a linear process going little by little. It's not good. They agree that's not good, but there is no place for alarmism, no place for panic. We don't have to do nothing special because maybe it's completely natural and okay, let's go with this. But like we said before, the climate change is a process full of feedbacks that increase climate change. When we heat the earth, we heat the permafrost liberate methane going to accelerate more the process. It's a feedback. When we are melting the ice not deflect the sun, it's also a feedback. When the ice is missing, it's more easy to heat the system, it's a feedback. When the oceans are unable to receive the CO2 and they are acid, it's also feedback because okay, it's a feedback. So in the end of the day, when all these gases are accumulating in the atmosphere, the process is going much faster, and empirically we see with our own eyes that really the process is really going much faster. So the model need to be adapted to what we see with our own eyes, because it's nice that the model will talk about some linear progression of warming, but in reality we see another situation, and so we need to adapt our theory, adapt our doctrine to the physical observation we see in practice. Okay, so let's talk a little bit about this graph that they describe like a linear one. Okay, we see here, this is temperature, this is time, and we see here we're going to 1 centigrade. Here is 1 centigrade, we get here we are in 2000, let's say 2019. The earth is heated to 1 grade centigrade more respect to the in confront of the previous temperature that Earth had in the 80s, something like this. I don't know exactly the numbers, but maybe 1 grade centigrade more than it was before. Here somebody say we are going like this. Somebody say we are going linearly. Maybe in 2010, maybe in 2000, in 2010, no, in 2100, in 2100, we're going to be at the 2 grade centigrade more than in the 80s. So maybe we're talking here about 2100, and the temperature will be here 2 grade centigrade. We are we are going up. In 2100, we are going to be only 2 grade more than in the 80s. Because if we are going linearly, then this is the phenomenon that we will get. Because they say, okay, if we took 40 years to get 1 centigrade change, maybe in the rest of 60 years we get another 1 centigrade change. Nothing happens, everybody happy. Who cares? We can keep throwing the CO2 into the atmosphere, no problem. But actually we don't know when the increase of the heating of the earth will take an exponential turn. Maybe we can go until 2030, and then it will take up, because there are so many feedback loops. Maybe in 10 years it will take up. Maybe it will happen. Maybe it will take it will happen in 2040, that we will have exponential increase in climate, in the temperature, because all of the feedback loops. But maybe we don't need to get to 2030 or 40 or 50. Maybe we are actually on the entrance, on the gate to enter this exponential heating of the earth. We don't know. This is you need to understand. And when these people tell you that we don't know, they may be that we are going exponentially right now, in 1 month, in 1 year maybe. So if we are going exponentially in 1 year, this is nothing. This graph is nothing. The earth, its creatures, its animals, it's the human population, it's nothing that we've seen before. This situation going from 1 centigrade to 6 centigrade, this is the end of civilization, the end of life on Earth, or maybe the possibility only for unique creatures to stay here, creatures that can live without oxygen in the atmosphere, in acidic ocean, an environment similar to prehistoric Earth. All of this is possible, and people say we're not going to lose Earth, we are only going to lose the possibility to live on Earth. Okay, so it's like saying that we will not lose Earth, because the planet will be able to return to its previous situation. The Earth will be able to grow life again, and this is a very optimistical view, because Earth will be able to host life once again. And we see it when we study the extinctions. They say that there have been 5 extinctions already. They study it on the base of the CO2 in the sediments, in the geological stratification, in the ice, and in the permafrost, and the other in the geological, in the earth, and in the stones. So actually we see that there were periods on Earth that CO2 concentration rose, and now we see that the Earth is having this atmosphere with oxygen and everything, and actually it's a very optimistic prognosis. But the question is how the human race will be able to withstand the period between the devastation of Earth and Earth that have impossibility for eukaryote and multicellular and the human existence to be present on its surface, until it will develop again its oxygen and nitrogen rich atmosphere. This is obviously the main question that any human being and anyone actually who have some conscience to ask himself if it's convenient for us to shift the Earth from a situation when it have a stable life-supporting atmosphere, oceans, and its own infrastructures of mountains, seas, land, and so forth, to a planet where the situation is completely unfavorable for life existence. And obviously it's for us it's convenient that the Earth will stay in its status quo like it is right now. And we are talking about an atmosphere rich of nitrogen, of oxygen, that is favorable for human existence. Okay. How can we solve the problem of climate change? Climate change is not some petty, simple phenomenon that somebody can solve with a move of the hand like this. Just let it be and it'll be okay. Climate change is the maturity test of humanity. Climate change is the beginning of the nature. It's the exam that the nature does to the humans to see if they are capable to survive. It's a test. Somebody call it a challenge, somebody call it opportunity. I don't know, maybe somebody call it a possibility to make